Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss qualitative analysis of organic compounds. Last class I have discussed about chromatography. Now I am going to discuss qualitative analysis of organic compounds. The elements present in organic compounds are carbon and hydrogen. This is a compulsory. The elements present in organic compounds are carbon and hydrogen. In addition to this, they may also contain oxygen, nitrogen, sulfur, halogen, and phosphorus. Halogen means fluorine, chlorine, bromine, and iodine. Determination of carbon and hydrogen. How we will determine carbon and hydrogen? Not determination, detection, because you are doing qualitative test. Only you have to detect it. Not a determination means quantitative. Here you are doing qualitative analysis, hence detection of carbon and hydrogen, because both will be done together, because carbon and hydrogen always will be there in any organic compound except for a drop of carbon. Everywhere carbon and hydrogen will be there, hydrocarbon. That's why it is detected simultaneously. Then how detection is done of carbon and hydrogen, I am telling you. Carbon and hydrogens are detected by heating the compound with copper oxide. Copper oxide means copper second oxide. Copper second oxide means CuO. Carbon present in the compound is oxidized to carbon dioxide and tested with lime water, which develops turbidity. If carbon dioxide will come, then how will you test it? Then it is tested with lime water, which develops, lime water will turn turbidity, and hydrogen present in organic compound will convert to water, H2O. H will also oxidize to H2O. And how will you test that water is formed or not? Then it is tested with anhydrous copper sulfate. Anhydrous copper sulfate. It will turn to blue. Means here you have heated given compound in presence of copper oxide, means CuO. Cu is in +2 state. CuO. What is the role of CuO here? Then it has oxygen. It will oxidize carbon and hydrogen both. Carbon will convert to carbon dioxide. It will oxidize carbon to carbon dioxide and hydrogen to H2O. And it is tested with carbon dioxide is tested with lime water. And lime water will turn turbidity, develops turbidity, and hydrogen, which is converted to H2O, that is passed through anhydrous copper sulfate, CuSO4. CuSO4, no water molecules, but when water molecules it will absorb, then it will turn to blue. It means that water is I can say formed. Water is formed. That is the test. Then now reaction you can write like this: C plus 2CuO. C means carbon plus 2CuO. On heating, it will give 2Cu plus CO2. 2CuO, it will convert to Cu, 2Cu, and it will give carbon dioxide. C plus 2CuO. Then 2 oxygen was there, 2CuO. That side becomes CO2 and only 2Cu is remaining, copper. That is the first reaction. First reaction when carbon dioxide will form from carbon. And for water, 2H, organic compound have both carbon and hydrogen. Then organic compound, if you will burn in presence of copper oxide, then these two reaction takes place. That is the carbon plus 2CuO. Carbon is present in compound. Then C plus 2CuO, it will give 2Cu plus CO2. And hydrogen present in compound, organic compound, that will give 2H plus CuO. 2H plus CuO, Cu plus H2O. This hydrogen will convert to H2O. 2H plus CuO. It will give, on heating, it will give Cu plus H2O. And carbon dioxide formed lime water. What is the lime water? Lime water is calcium hydroxide. Aqueous calcium hydroxide means a solution of calcium hydroxide. Then CO2 plus CaOH whole 2. It will react and it will give calcium carbonate. That is actually turbidity plus H2O. Calcium carbonate will precipitate. Then CO2 plus CaOH whole 2. It gives CaCO3 precipitate. You can give a sign also. Precipitate sign is down, towards down, arrow sign towards down, means it is a settling. Then CO2 plus CaOH whole 2, it gives calcium carbonate plus H2O, calcium carbonate precipitate. And this water molecules means H2O, 5H2O plus copper sulfate. 5H2O plus copper sulfate, it will give copper sulfate 5H2O. Its color will be blue. Now this I have told you detection of carbon and hydrogen. Now detection of other elements. Nitrogen, sulfur, halogen and phosphorus present in organic compounds are detected by Lasigness test. LASSAIGNES, Lasigness test. All these are, except carbon and hydrogen, other elements are tested or detected by Lasigness test. The elements present in the compounds are converted from covalent form into the ionic form by fusing the compound with sodium metal. This is the important things. Here, Lasigness test, by Lasigness test, you will detect all other elements except carbon and hydrogen. Then here, actually, organic compounds generally all will have covalent bond only. Then that covalent bond, now it will convert to ionic bond with treatment with sodium metal, by fusing with sodium metal. Okay. Then here now sodium metal, suppose carbon and nitrogen was there, organic compound, suppose now we are doing for the nitrogen. All three I will tell. If nitrogen is present in organic compound, then you have done, you can say, this fusing the compounds with sodium metal. Sodium metal means compound plus sodium metal, and you are heating, red heat, strongly you have to heat. And after heating, what will happen? That sodium plus carbon plus nitrogen, because nitrogen may be attached with carbon only, with carbon. Then sodium plus carbon plus nitrogen, it will give on a strong heating in a small fusion tube will be there. In that you have to take all the things, compound plus a small piece of sodium, and you have to heat strongly. Okay. Then it will give Na plus carbon plus nitrogen. On heating, strong heating, it will give sodium cyanide, NaCN. Then now covalent bond now converted into ionic bond, NaCN, Na plus Cn minus. And suppose now sulfur is there, then it will react with sodium. If sulfur is present in the organic compound and you are heating with sodium, then it will give Na2S. It will form Na2S, sodium sulfide, 2Na plus S. On heating, it will give Na2S. And if halogen is present, means X, capital X, then it will give NaX. Then this is also ionic compound, NaX, NaCl, NaBr, NaI, NaF. And this Na2S is also ionic compound. Na2 means Na plus S2 minus. Then all are ionic compounds, means from covalent compound now it converted to ionic compound with the treatment with sodium metal. Carbon, nitrogen, sulfur and X comes from organic compound. Cyanide, sulfide and halides of sodium so formed on sodium fusions are extracted from the fused mass by boiling it with distilled water. Means in fusion tip, sodium you will take and organic compound you will add, and if you will heat a strongly red heat, when it will come complete red, then you put in the water and just crush it completely. Then in that water, all you can say, all will dissolve in the water. That is called extraction. Okay, that in that water it will dissolve all. You can filter it. That in the filtrate, means in solution, that is called extract. This extract is known as sodium fusion extract. Sodium fusion extracts. If you will go to the lab and you will do organic analysis, then first you have to do, after carbon and hydrogen test, you have to do this. You have to make this sodium fusion extract you have to make, and for only from this extract, sodium extract solution or sodium fusion extract, you will do the test for all these elements, means nitrogen, sulfur, phosphorus, hydrogen. Every time you will take this sodium fusion extract solution you will take in a small quantity always for each test, and you will do the test. Always you have to take this sodium fusion extract. Then now test for nitrogen. How will you do the test for nitrogen? Now I am telling you. Always you will use this extract only, because compounds are present only in this extract, and it is converted into in the sodium salt like NaCN, Na2S, NaX. Okay, the whatever you are going to do test one by one. Then now test for nitrogen. The sodium fusion extract is boiled with iron sulfate FeSO4. Ap is in +2 state. Okay, Ap sulfate. The sodium fusion extract is boiled with iron sulfate and then acidified with concentrated sulfuric acid. Two things you are adding. First, you have added ApSO4, sodium extract solution, or the fusion extract, sodium fusion extract, plus ApSO4 plus concentrated H2SO4. Then what will happen? Total three things I have added, means sodium fusion extract plus ApSO4 plus concentrated H2SO4. Then it will form, you will get new things. The formation of, you will see now solution became blue, Prussian blue, Prussian blue, Prussian, Prussian blue, blue color. This, the formation of Prussian blue color confirm the presence of nitrogen. This is very, very important test. In examination, question is asked for each test. Then Prussian blue color confirms the presence of nitrogen. Means in compound nitrogen is there. If Prussian blue will come, develop, it means confirm that compound has nitrogen. If not, then compound is nitrogen is not there. If blue color will not form, then nitrogen is not there. If blue color will form, Prussian blue, then nitrogen is confirmed. Now, sodium cyanide first react with iron. Now, reaction I am telling you. Sodium cyanide, NaCN. N is there, NaCN. Sodium cyanide first react with iron sulfate, means ApSO4, and forms sodium hexacyanoferrate. After the reaction, it will form sodium hexacyanoferrate, means sodium cyanide will react with ApSO4 and it forms hexacyanoferrate second. Ferrate second means second oxidation state second. And after that, this you will heat. What first you mix two. Now third things you are adding H2SO4. On heating with concentrated sulfuric acid, means H2SO4, some iron second, Ap2 plus. Ap2 plus ions are oxidized in presence of iron ions. Okay. On heating with concentrated sulfuric acid, some iron second means Ap2 plus ions are oxidized to iron 3 plus. Iron 3 plus means Ap plus 2 converted to Ap3 plus. Ap3 plus ion which react with sodium hexacyanoferrate. Correct. Iron third, it will react with hexacyanoferrate second to produce. Now, second is also there, third is also there. This is very, very important. Third is reacting with hexacyanoferrate second to produce iron third hexacyanoferrate second. Means now you can see here both oxidation state is present. Both oxidation state +3 also, iron +3 and iron +2. Then this compound will be iron third. Okay, this after reaction it will produce iron third hexacyanoferrate second. This is also called ferriferrocyanide. Ferriferrocyanide, very, very important. Question is asked. Ferrocyanide. It is ferro and ferri. And ferro means +3. Ferri means +2. Okay. Then ferri and ferro. Ferri +3, ferro +2. Ferriferrocyanide cyanide. It is also called ferrocyanide. Otherwise, iron third hexacyanoferrate second, which is Prussian blue. This is called iron third hexacyanoferrate second. That is the ferrocyanide is called Prussian blue in color. Its color will be blue. Okay, this question is asked. 2-3 question is asked only from this. Now reaction, if you want to write, you can write the reaction also. 6CN 1 minus cyanide ion. 6 cyanide ion means 6CN1 minus plus Fe2 plus, it gives FeCN whole 6. It will give complex FeCN whole 6 and outside 4 minus. This is the coordination complex ion it is. FeCN whole 6 and outside, write in FeCN whole 6 in bracket and outside 4 minus. And this FeCN whole 6 4 minus, it will react with Fe3 plus. Fe3 plus it will react and it will form, but at balanced equation I am telling you 3FeCN whole 6. 3 molecule you have to write. 3 molecule. 3 FeCN whole 6 4 minus means 3 ions. 3 ions you have taken plus 4Fe3 plus, and then in presence of some water, it will react and will give Prussian blue. It will give Prussian blue. Prussian blue, you can write like this way also. Fe4 outside and in bracket you write FeCN whole 6. Fe4 outside and in bracket FeCN whole 6. And this FeCN whole 6 you have written in bracket, big bracket, that is a 3. Outside 3 you have to write, means 3 more. Fe4 means 4 Fe you have taken, 4 Fe4, and in big bracket you have written under big bracket FeCN whole 6. Then FeCN whole 6 is down you have written 3 molecules. Then and XH2O will be attached. XH2O will be attached. This is called Prussian blue. Again, finally I am telling you, Fe4 in big bracket, Fe4 is outside, inside the bracket, big bracket, FeCN whole 6, and outside of big bracket, it down you write 3, and XH2O. You don't know how many X is there, maybe 2, 3, 4, 5. XH2O. This is called Prussian blue. Now, how will you do the test for sulfur? Then now I am going to tell about the sulfur, test of sulfur. The sodium fusion extract. Now again you will take sodium fusion extract. The sodium fusion extract is acidified with acetic acid and lead acetate. 2 things you will use here. Acetic acid plus lead acetate. And if in organic compound, if in the compound sulfur is present, then that sulfur will react with these 2 reagents, means with acetic acid and lead acetate. Then what you will get? You will get black precipitate. A black precipitate of lead sulfide you will get, lead sulfide, PBS you will get. Its color will be black. That will confirm presence of sulfur in the given organic compound. Okay, means here sulfur suppose in the compound was present, then S2 minus sulfur will be in the sulfur ion, it will be S2, Yeah, I told you that this sulfur will convert into the sodium sulfide in with metallic sodium during the formation of extract. Sodium extract fusion, that time it converted into Na2S. The S has two negative charge. Na2 means two positive is there, sodium, sodium. Then to balance these two positive, sulfur will be two negative. Then S2 minus. S has 2 minus. Then now that S2 minus plus lead, because lead acetate you have added, then both will react. S2 minus plus lead 2 plus. Lead 2 plus. It will form lead sulfide. Lead sulfide. PHIDE. Not sulfide. 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 PHIDE. Okay. SO3 is sulfide. SO3 2 minus is sulfide. Okay. But here lead sulfide PBS. That is the first test you have done. Sulfur first test. Sulfur second test also you should know. On heating sodium fusion, sodium fusion extract with sodium nitroprusside. Sodium nitro, this is also very, very important test. Okay. And important tests also are important for exam also. On treating sodium fusion extract with sodium nitroprusside, appearance of a violet color further indicates the presence of sulfur. Means if you will treat it with nitroprusside, sodium nitroprusside plus sulfur, it will give you violet color. Violet color further indicates the presence of sulfur. Appearance of a violet color indicates the presence of sulfur. The second test. Then what is actually this? Sodium nitroprusside. Sodium nitroprusside, I am telling you. Sodium nitroprusside is FeCN5NO. This is a complex anion. It has two negative charge. Anion, two negative charge. FeCN5NO. This is actually sodium nitroprusside. Actually, this will react with sulfur. Actually, Na you have not written. Only you have written nitroprusside. Sodium in the place of sodium 2 minus is there. Okay, ion only you have written. Ionic complex. Anion. FeCN5NO 2 minus. 2 sodium you are only ion you are considering. Then this plus S2 minus sulfur. Both will react and it will form. All thing is the same. Only S will attach there. Only S will attach there. Means FeCN5NOS. And this 2 minus was there and again 2 minus. Total 4 minus. Hence outside it became 4 minus. And this compound FeCN5NOS 4 minus, its color is violet. Its color is violet. In case nitrogen and sulfur, now you have done if sulfur is present, then I have given two tests. One is making lead sulfide with treatment with lead acetate plus acetic acid. Second, you have done treatment with sodium nitroprusside. Now, this was the separate, when only N was there or when only S was there. But now think, if both are present in the compound, N and S, both are present, then in case nitrogen and sulfur both are present in an organic compound, sodium thiocyanate is formed. This is very, very important things I am telling you, that if both are present, then it will form sodium thiocyanate. Thio means sulfur. Thio means sulfur. Correct? Don't forget. It will form sodium thiocyanate is formed, and it gives a blood red color and no Prussian blue, since there are no free cyanide ion. A free cyanide ion, then it will give these things blue color, Prussian blue. But there is no free cyanide ion. It will give red, blood red color. Blood red, just like a blood color is there, red, like that type of, it gives a blood red color. It means both are present. It means nitrogen and sulfur both are present. Okay, and reaction you can write already, Na plus C plus N plus S. That is the NaSCN. In the beginning you have seen Na plus N, that was Na plus C plus S. Sodium cyanide was there. Extraction time. But now nitrogen and sulfur both are there, or carbon is also there. All both actually, nitrogen, and why carbon is in the middle you are writing? Because nitrogen and sulfur will be attached with carbon. That's why carbon you are writing here. Then Na plus C plus N plus S. It will give NaSCN, sodium thiocyanate. Then here see NaSCN. S is also there. N is also present there. Then this is the sodium thiocyanate. And after that, this with ferric Fe3, with ferric chloride only, Fe3 ion is there. Then this SCN will react. This SCN will react, and it will form FeSCN. Is a complex, it will form with 2 minus, anion it will form FeSCN. This complex, and complex has 2 negative, 2 minus. This is actually blood red. Blood red it will give only in presence of ferric ion, Fe3 plus ion. Fe2 plus ion is called ferrous, and Fe3 plus is called ferric. Then Fe3 plus SCN, 1 minus, it will give SCN, FeSCN, and outside 2 minus is there. 2 plus is there, not minus, 2 plus is there. This is the, because iron is a 2 plus. Fe3 will convert to the Fe2 plus. Fe2 plus. Okay, because this Fe3 plus and 1 minus, SCN has 1 minus, then obviously 3 plus will become 2 plus. Hence FeSCN, you write in a big bracket, outside 2 plus. Its color is blood red. Okay. If sodium fusion is carried out with excess of sodium, again you listen. If sodium fusion is carried out with excess of sodium, then what will happen? The thiocyanate decomposes to yield cyanide and sulfide separate. These ions give their usual color, usual test it will give. Okay, means NaSCN is there, and you have added more sodium. If sodium fusion is carried out with excess of sodium, then NaSCN means sodium thiosulfate, sodium thiocyanate, NaSCN plus 2Na, it will give NaCN plus Na2S. This reaction is also important, but it is in excess sodium. If sodium extract will take more, means sodium should be more. Then NaCN plus 2Na, it will give NaCN plus Na2S. Simple. They will give sodium cyanide plus sodium sulfide. If in sodium extract more sodium is there, okay, means that sodium thiocyanide, sodium thiocyanate will decompose and it will give sodium cyanide plus sodium sulfide. Okay, not sulfite. So Na2S, okay, sulfide. Now test for halogen. The sodium fusion, again you will take sodium fusion extract. The sodium fusion extract is acidified with nitric acid. Now you are using nitric acid, you are added, and after that main reagent you are adding, and then treated with silver nitrate. Silver nitrate is the main reagent. Okay, then sodium extract plus nitric acid plus silver nitrate. Main reagent is silver nitrate. Then here AgNO3, silver nitrate is there. And actually here you are adding nitric acid, HNO3. This is only just simply for, you can say, buffer, as a buffer solution, common ion effect. For that common ion effect, you are mixing nitric acid. Main reagent is silver nitrate. Then silver nitrate, and if in an organic compound, suppose organic compound has X, then it will form AgX. Silver X means silver chloride, silver fluoride, silver bromide, silver iodide. Directly AgNO3 will react with X minus, means Cl minus, Br minus, F minus, I minus, and it will form AgX, means silver chloride, silver fluoride, silver bromide, silver iodide. Simple reaction is there. AgNO3 plus can say Cl minus, any X minus, then AgX. Ag plus X minus, it will form AgX. Precipitate you will get. Now precipitate you will get. Then what is the color of the precipitate? That will tell about the exact halide, whether it is fluoride, chloride, bromide, iodide. By the color of the silver halide, you will understand. A white precipitate soluble in ammonium hydroxide. If a precipitate is white, suppose you got the white precipitate and it is soluble in ammonium hydroxide. Ammonium hydroxide is also always you have to treat with ammonium hydroxide. Okay, actually this will confirm the final which type of halide is there. Then a white precipitate soluble in ammonium hydroxide shows the presence of chloride. If white is there and soluble in ammonium hydroxide, that precipitate is soluble in ammonium hydroxide. It means chlorine is present there, presence of chlorine. And if precipitate is yellow, if suppose you got yellow is precipitate, sparingly soluble in ammonium hydroxide. In ammonium hydroxide it is not fully soluble, sparingly, very less soluble. Then shows the presence of bromine. And again suppose yellow precipitate is there and insoluble in ammonium hydroxide, not soluble, then not soluble, and it is yellow, then it shows the presence of iodine. Insoluble in ammonium hydroxide, but precipitate is yellow only. Both are yellow, but one is sparingly soluble, others are not soluble, insoluble. Insoluble means insoluble in ammonium hydroxide shows the presence of iodine. Then X plus Ag plus AgX. Here reaction will not take place with fluorine, only with chlorine, bromine, iodine. Okay, because water is there. Fluorine reacts vigorously with water. That's why fluorine can't be tested like this here. Then X represents a halogen. Now, if nitrogen or sulfur is also present in the compound, now see, suppose nitrogen is also present, sulfur is also present, and halogen is also present. All three are present. Then how will you do test? All three, nitrogen, sulfur and halide, all three are present. Then for that I am telling you, if nitrogen or sulfur is also present in the compound, then the sodium extract fusion or sodium fusion extract is first boiled with a concentrated nitric acid. First treatment is with nitric acid to decompose cyanide or sulfide of sodium, okay, formed during the Lasignate test. That time you have this sodium cyanide is formed. Sodium cyanide or sulfide all are formed that time, and during the making of this extract, fusion extract. During Lasignate test, that time this might be formed. These things, sodium cyanide, sodium sulfide form. Then now it will decompose. To decompose this cyanide or sulfide of sodium formed during Lasignate test, this you are treating with concentrated nitric acid because it will decompose. Okay, sodium cyanide or this sodium sulfide, if it was there, that will decompose. After that, what will happen? These ions would other, if you will not do all the things, why you are doing, if you will not do other things, if it will not decompose, then it can interfere with silver nitrate test. It can interfere with silver nitrate test. Hence, it is treatment is done with nitric acid also. Then this I have told you that because you don't want that time the sodium cyanide during halogen test time, you don't want sodium cyanide or sodium sulfide. Nitric acid you have added, that is one more purpose is that it will decompose. It will decompose sodium cyanide and sodium sulfide. Then it will not interfere with halogen test. Now I am going to tell you about the test for phosphorus. Test for phosphorus. How will you do the test for phosphorus? Just now you listen. Last test is test for phosphorus. The compound is heated with an oxidizing agent. Means now we will take again extract, fusion extract. You will take sodium fusion extract. You will take. The compound is heated with an oxidizing agent. Which oxidizing agent? Then sodium peroxide, Na2O2, sodium peroxide. H2O2 is the hydrogen peroxide. In the place of H, Na you take, sodium peroxide. Then now heat it. Compound is heated with sodium peroxide. Then what will happen? This is oxidizing agent. It means it will oxidize. The phosphorus present in the compound is oxidized to phosphate. It will it will oxidize to phosphate. The solution is boiled. Because now phosphate formed, the solution is boiled with nitric acid and then treated with ammonium molybdate. Here ammonium molybdate very less it is used. In very less test it is used. It is very popular and known as only for phosphate test. Keep in mind, ammonium molybdate test, it is also called ammonium molybdate test. It is very popular. It is used very less used, and it is only in the phosphate test, ammonium molybdate test. MO, that is symbol is capital L, small o. Okay, then this when you have treated with nitric acid, then after that you have to boil it. The solution is boiled. The solution is boiled with nitric acid and then treated with ammonium molybdate. Then you will get a yellow color you will find, yellow coloration or precipitate you will get, which indicate the presence of phosphate. Okay. Nitric you have used with what? You have just taken nitric acid, you have done molybdate, added ammonium molybdate, and you have heated. Simple things. Extract solution plus nitric acid plus ammonium molybdate plus this. In the beginning you have done heated it with sodium peroxide. First you have done heated with sodium peroxide. Then it converted to phosphate. Phosphorus converted to phosphate. And after that you are doing two tests. You are heating it with nitric acid plus ammonium molybdate. And if it gives yellow coloration or precipitate, it means it indicates the presence of phosphate. Reaction you can write like this. Na3PO4 means sodium phosphate. PO4 has 3 minus. PO4 has 3 minus anion, phosphate anion. Then to neutralize 3 negative, 3 positive is required. Then Na3. Each Na has 1 plus. Then Na3PO4 plus 3HNO3 plus 3HNO3, it will give H3PO4, phosphoric acid. H3PO4 means phosphoric acid plus it will give 3NaNO3, sodium nitrate. This sodium phosphate will react with nitric acid, means Na3PO4 plus 3HNO3. It will give phosphoric acid, means H3PO4 plus 3NaNO3. And this phosphoric acid H3PO4 is or you can say this H3PO4 reacts with ammonium molybdate solution. This phosphoric acid will react with ammonium molybdate, and this reaction will take place. Already nitric acid is present there. Then this phosphoric acid will react in the presence of nitric acid and molybdenum. Ammonium molybdate means for the reaction this phosphoric acid what form? That phosphoric acid plus ammonium molybdate plus nitric acid. It will give you ammonium phosphomolybdate. Its color is yellow. Now balanced reaction I am telling you, this reaction is very, very important for examination, and in a lab this test is very popular. Ammonium molybdate, phosphate test for ammonium molybdate. Then now balanced equation I am telling you, H3PO4 plus 12 molecules you have to take ammonium molybdate, means 12 NH4 whole to MoO4. MO means molybdate. MO means molybdate, O4. Ammonium molybdate formula is NH4 whole 2 MoO4. Again I am telling you, NH4 whole 2 MoO4. This is the ammonium molybdate. Then 12 moles you have to take. H3PO4 plus 12 moles of ammonium molybdate plus 21 mole of nitric acid. This reaction is special. Quickly you will remember, because in other reaction you will not get co-percentage like a 12 or 21. But here ammonium molybdate is 12 moles and nitric acid is 21 mole. Then after the reaction it will give ammonium phosphomolybdate. Its formula is NH4 whole 3 PO4. NH4 whole 3 PO4, and in that 12 MoO3 is absorbed. Okay, ammonium phosphomolybdate. Here two parts is there. Ammonium phosphomolybdate. Then ammonium phospho, how will you write? Then ammonium phospho will write NH4 whole 3 PO4. Just like iron phosphate, here iron phosphate, like that way ammonium phosphate, NH4 whole 3. 3 is for phosphate has 3 negative, that's why NH4 whole 3. Correct? And this NH4 has 1 plus, that's why PO4 only 1 is there, that you need not require to write. Then NH4 whole 3 PO4, and dot you can write or point you can write 12 MoO3, means 12 molybdate ion is absorbed. That is called ammonium phosphomolybdate. NH4 whole 3 PO4, that is called ammonium phospho, and in that it is a 12 MoO3 molybdate is attached. Then now it became NH4 whole 3 PO4 12 MoO3 plus other product is 21 ammonium nitrate, 21 NH4NO3 ammonium nitrate, 21 moles, and 12 molecules of water, 12 moles of water, 12H2O. Then 3 products are there. After the reaction it will give 3 products, that is the ammonium phosphomolybdate, ammonium nitrate plus water. Okay. Then this ammonium phosphomolybdate color is yellow color. This I have told you about all test of this means carbon. All test means here carbon test, hydrogen test, halogen test, nitrogen test, sulfur test, phosphorus test. All these are very, very important for examination as well as in lab also. When you will go for this qualitative test in examination, it is asked. In that time this will help you. And now I am stopping only here, and next class I will discuss quantitative analysis, because it will take more time. Okay. Thank you.